the cotangent function. And the inverse cotangent function. We know cotangent, that is cot x, is the reciprocal of tan x, that is 1 by tan x. For all real values of x, except when tan x is equal to 0, except when tan x is equal to 0, that is x is the integral multiples of pi, that is n pi, where n belongs to the integer z. The domain of cotangent function is in the range, that is excluding n pi such that n belongs to z. So this is the domain of cotangent. That is cot x. And its range is, so the real number excluding n multiples of pi such that n belongs to z. Now let us explain about the range, its range. So range of cot x. It lies in the open interval from minus infinity to plus infinity. Like tan x, the cotangent function is an odd function. So cot x is an odd function. And it is periodic with the period pi. So its period is pi. Now let us explain about the graph of this cotangent function. The cotangent function is continuous on the set 0 to pi, excluding pi. So the cot function is continuous on the set that is 0 to 2 pi with an open interval but excluding the pi. The cotangent function on 0 to 2 pi excluding this pi. Let us study the graph about that. In the first quadrant and third quadrant, cotangent takes positive value, is it not? first, second, third, fourth, all silver tea cups. So in the first and in the third, tangent and cotangent, they take the positive values. In the second and the fourth, they take the negative values. So this is very clear. Now the cotangent function has no maximum value and no minimum value. So this point should be highlighted. It is not like sine or cos. So there is no maximum value. Similarly, no minimum value. Excuse me. Now the cotangent falls from infinity to 0. It falls from infinity to 0 for x that belongs to the interval 0, pi by 2 with the open interval and closed interval on the right side. Then it falls from zero to minus infinity for the x value that lies between the closed interval starting with pi by 2 and pi with the open interval. Then it falls from infinity to 0 for which value? For x that belongs to open interval of pi by 2 comma closed interval of 3 pi by 2. Then it falls from 0 to minus infinity. 0 to minus infinity. For which value? For x belongs to 3 by 2 pi, that is 3 pi by 2 comma pi 2 pi with the open interval. Okay. Now let me explain about this graph. Let us draw the graph first. Let us draw y is equal to cot x. This is the y-axis. This is the x-axis. Now, this is the origin 0 and we have pi and we have 2 pi. Now, as I already explained, the graph goes like this. In fact, this is pi by 2 And what about this one? This is 3 pi by 2. Okay, right. Now let us proceed the graph, and you can mention this pi value. You can draw a dotted line here. Okay, right. Now it crosses, it falls from y. Okay, crosses pi by 2 and it doesn't touch pi. Similarly, it crosses 3 pi by 2 and doesn't touch 2 pi, but it is very closer to 2 pi. So this is the y is equal to cot x. Okay, y is equal to cot x in 0 to 2 pi. Okay, with the open interval, excluding pi, the set of pi. So you can observe here there is no curve noticed here. It is not intersecting pi, and that is why we have put excluding, okay, pi. So otherwise it covers 0 to how much? 2 pi, excluding the pi. Do you understand? Right. Now let us have another graph. Y is equal to cot x with the complete values. Let me draw here. X-axis, this is minus x, the domain and the range y-axis. So this is y, this is minus y. Let us have pi, 2 pi, 3 pi, etc. Similarly, we have minus pi, minus 2 pi, minus 3 pi. Okay, so pi, 2 pi, 3 pi. This one is minus pi, minus 2 pi, minus 3 pi. Now let us have this zero to 2 pi excluding pi repeated for the subsequent 2 pi, 4 pi. Okay, so for subsequent 2 pi, 4 pi. Okay, with the open interval, but excluding 3 pi. Okay, so here 3 pi is excluded. Similarly, 4 pi and then 6 pi excluding 5 pi. Got it? So this you should note down. So and so on. And we can write down for negative also. How we can proceed? Minus 4 pi, comma, minus 2 pi, excluding minus 3 pi. Okay, so this is the way you have to write down the set. And can you tell me for 2 pi? So you have minus 2 pi and 0, excluding pi. Got it? That is minus pi. Okay? Excluding minus 2 pi 0 and excluding 2 pi comma 0 excluding minus pi. So the entire cotangent function can have the domain. It can be generalized as the domain real number excluding n pi where n belongs to the integer. Okay, now let us draw. So 0 to pi, it will have like this, and let us have the values 1, 2, 3, 4, etc. That is range 2, 3, 4, 5, minus 1, 2, 3, 4, 5. So it is very closer, but it doesn't come across what? The pi. So you can put a dotted line like this in order to show that it doesn't cross. Similarly for 2 pi. Similarly for 3 pi. Okay, and here also minus pi, minus 2 pi, minus 3 pi. Okay, so let us draw it carefully. So you can draw, and it should cross via pi by 2. Okay, right, and similarly here crosses via in between pi and 2 pi. Okay, in between 2 pi and 3 pi. Okay, so similarly minus, it crosses via minus pi by 2 and does not touch 0. Similarly here it should cross like this. Okay, it should cross like this. Okay, got it? Right. Now let us have this once again. See that it falls from infinity to 0. So it falls from infinity to 0, and for which x belongs to 0 to pi by 2. X belongs to 0 to, in the interval 0 to pi by 2. Falls from 0 to minus infinity. 0 to minus infinity, where x ranges from pi by 2 to pi. So pi by 2 to pi. Here it is closed interval, so I have shown this as closed interval, and here it is an open interval, so I have not touched any line, there is no intersection. Similarly 0 to minus, then infinity to 0, again infinity to 0, and then it crosses pi by 2, then 3 pi by 2. So pi by 2, it crosses from pi by 2 to, pi by 2 to pi. Okay, so pi by 2 to pi, that is over. Then pi by pi to 3 pi by 2. So I should write this as pi to 3 pi by 2. Okay, pi to 3 pi by 2, and then 0 to infinity, negative infinity, 0 to infinity. So 3 pi by 2, 2 pi. So 3 pi by 2 closed interval, and here open interval up to 2 pi. So it does not come across, maybe closer. Okay, are you able to understand this? So this is the graphical representation of cotangent. So let me summarize. Cotangent, or the inverse and the inverse cotangent function. Now we are considering the cotangent function. The cot x is nothing but the reciprocal of tan x, and here tan x is equal to 0, so x is equal to n pi. It is excluding this. So this can be represented as in a set builder form. The domain can be explained as or excluding, that is except n pi and n such that n belongs to z. So it ranges, the ranges from minus infinity to plus infinity. So that is minus infinity to, plus infinity to minus, or minus infinity to plus infinity. Now the period is pi. So the period is pi. Okay, the period is pi, 2 pi, 3 pi means pi. Here the extreme is this one and this one. So pi. Now cotangent function is a continuous on 0 to 2 pi excluding pi. So we have taken only one thing, 0 to 2 pi excluding the what? Pi. So here it doesn't come across pi. Are you able to follow? Right? So there is no maximum value as in the case of sine and cos. Okay, there is no minimum value also. So we have explained how it falls from infinity to 0, 0 to minus infinity. Again infinity to 0, 0 to minus infinity for the respective x values. Okay. Then we have explained about the positive values of tan and cot, that is in the first quadrant and the third quadrant, and they are negative in the second quadrant and fourth quadrant. And for the complete set we have explained here. Okay.